Yeah, again, I'm happy to welcome you in our tap room. My name is Alex Karolets. I'm the solutions engineer here at Starwind. And the main theme we'll be talking about today is the vSphere environment. So, which sauce is needed to eat that and what we can do to make it better. Okay, the vSphere environment. VMware vSphere leverages the power of virtualization to transform data centers into simplified cloud computing infrastructures and enables IT organizations to deliver flexible and reliable IT services. So VMware vSphere virtualizes and aggregates the underlying physical hardware resources across multiple systems and provides pools of virtual resources to the data center. And generally, as a cloud operating system, vSphere manages large collections of infrastructure, such as CPU, storage, networking, as a seamless and dynamic operating environment, and also manages the complexity of data center. There are also certain requirements to achieve the well-functioning VMware environment. The configuration must be correctly provisioned, connected within network topology, and must have sufficient amount of compute and storage resources. Like in each vSphere environment, in my opinion, the most important thing is to properly build the compute platform according to production requirements. And first, I'm going to talk a bit about the named NUMA definition. So the NUMA abbreviation defines non-uniform memory access. And by using the NUMA architecture, each CPU has its own local memory, RAM. Thus, together they make a NUMA node. In the two-socket system, there are two NUMA nodes, and accordingly, four-socket nodes have four NUMA nodes, etc. By using the NUMA architecture, the operating system will try using the resources of a single NUMA node, but if the question of using more resources will occur, the resources of the second NUMA node can be used in this case. So by requesting the remote NUMA node, there will be a task delay, which will affect negatively on the overall system performance. Basically, how we can fix that is the proper vCPU sizing. So many admins think that more vCPU will be assigned to the virtual machine, more tasks this virtual machine will perform, making it even faster. But that's not true. That's quite not true. E6i hypervisor completely supports NUMA architecture. Moreover, it was built on top of it, and the hypervisor itself will apply the named round-robin resource utilization politics between the NUMA nodes to get the maximum performance. So this means that both NUMA nodes will always work. So the virtual machine that is being run on NUMA 0, that's the first one, will use the resources of this NUMA node without touching the remote NUMA node. But the amount of the resources is sufficient. But if it's not sufficient, the resources of the partner remote NUMA node will be requested. Thus, it will increase the response time and latency, which will result in performance decrease. According to the architecture principles of the server CPU work, the number of vCPU per virtual machine doesn't need to exceed the number of physical cores of the single NUMA node or single socket in order not to use the remote NUMA node. So the general advice, less CPUs, more often virtual machine gets into the physical core, thus the response of the VM is better, and the latency is smaller. While planning the virtual machine size, start with giving a single vCPU to the virtual machine. If that's not enough, add the second one. If it still doesn't work, increase the number to 4 vCPUs, but not exceed the number of the physical cores of the CPU within the NUMA node. So there's also the vSocket or multi-core vCPU. The principle is the same as with vCPUs, but it will allow to reach the CPU's physical cores more frequently alongside with the bigger amount of vCPUs needed. Moving next, RAM optimization. The same as with vCPUs, RAM memory also highly dependent on NUMA nodes. There is a RAM memory amount of like on each CPU of your servers, which the CPU has the direct access to and forms the NUMA node. The device on the RAM is on the RAM memory is quite simple. RAM capacity assigned to the virtual machine doesn't need to exceed the RAM capacity on one of the NUMA nodes to avoid using the remote NUMA node resources. And also, nowadays, in order to achieve the maximum performance on the latest Intel Scalable family CPUs and DDR4 RAM within the single NUMA node, it is recommended to have 6 or 12 RAM sticks per CPU. So it will be like 12 or 24 RAM sticks in total for 2-socket systems. Thus, the CPU can squeeze the maximum performance out of RAM memory. Okay, moving next. And whereas the production VMs and data are, there is a storage. So we need to store the files thanks to the technologies we have. Wide number of options these days. There can be SSD drives, spindle drives, volatile memory, and VMEs, etc. And giving just the random amount of drives to the vSphere won't do the job, or it will do, but will be an overkill, or it can be insufficient to run VMs on it. So the recommendation here is to provide proper underlying RAID array to meet the IOPS demand. So the SSDs can be in RAID 5 or RAID 10. HDDs are recommended to go with RAID 10 also. Another thing is about using pass-through to give the drives directly to VMs avoiding network level. In case of hybrid configurations, if you want to use the tiered storage, for example, that's how we use the storage spaces in virtual SAN. It will be better to give the already rated storage as a single data store instead of giving each drive separately and then making the tiering. So this will significantly increase the number of IOPS. So yeah, something like that. Okay, so when it comes to the VM storage provisioning, it is recommended to create thick provisioning user disks. It simply means that all the space that is required for the virtual disk files is reserved when VMs is created. So the phrase zeroed out means that blocks on the physical storage device are formatted with the zeros to overwrite any old data. And using this type of provisioning will improve the overall storage performance and will allow you to properly plan your infrastructure in terms of storage, not being hit by insufficient storage warning in case of future growth. When you use the vCenter server and vMotion or DRS, make sure that LUNs for the virtual machines are provisioned to all ESXi hosts. This provides the most ability to move virtual machines. When you use the vMotion or DRS with an active passive SAN storage device, for example, make sure that all ESXi systems have consistent paths to all storage processors. Not doing so potentially can cause path trashing when a vMotion migration occurs. And another big question I wanted to touch on today is the networking. maybe the most interesting part of the server infrastructure for me, at least. Just because if you use more than one host in your server infrastructure, you need to do the networks in the right way and to make the cluster turtle. So using more than one VMware ESXi server most probably means that you have the cluster. So generally, there are two types of clusters: on-premise and stretch clusters. Let's talk about on-premise clusters first. And of course, everything here is relevant to the stretch clusters as well. So one of the important things is the network I/O control. When the network I/O control is enabled, the distributed switch allocates bandwidth for the system traffic types, such as fault tolerance traffic, iSCSI traffic, NFS, vMotion, etc. And it basically applies the share value set to each traffic type. Thus, less important traffic, as defined by the share percentage, will be throttled, allowing more important traffic types to gain the access to more network resources. So the network I/O control also allows the reservation of bandwidth for system traffic and enables proper resource control at the virtual machine network adapter level that looks similar to the vCenter CPU and memory reservations. Okay, so the storage disk shares. You can change the disk resources for a virtual machine if multiple virtual machines access the same VMFS data store and the same logical unit number. Use disk shares to prioritize the disk accesses from the virtual machines. So the disk shares distinguish priority from low priority virtual machines, and shares is a value that represents the relative metric for controlling the disk bandwidth to all virtual machines. So the values are compared to the sum of all shares of all virtual machines to the server on an ESX host, the service console. So you can use the share value by using the low, normal, high presets, as well as use the custom value. So most important VMs can be set with the disk shares value at 4000. So it is also good to use the limitation of IOPS in order to correctly distribute the network resources. You can set the IOPS limitation to certain VMs that will not exceed the, like in any case. Another option will be to use the NIC teaming. So this will maximize the networking capacity utilization by teaming several network ports into a single bandwidth connection. But please take into consideration that using NIC teaming with the iSCSI protocol can cause the performance issues because of increased latency. It is recommended to use multipathing instead, especially if the production generates big amount of small write and read operations. Okay, moving next, jumbo frames. Jumbo frames reduce the CPU load caused by transferring data. It is recommended to enable jumbo frames on a network interfaces by changing the maximum transmission units of the VM kernel interface to the value of 9000. So also jumbo frames must be enabled on all network switches and NICs. Please take into consideration that some network adapters can face some performance issues when the jumbo frames are set at 9000 value within using the iSCSI protocol. So from my knowledge, several keylogic NICs have such an issue, so it is recommended to leave the jumbo frames value default on 1500 on these network cards. especially the ecologic ones. Okay, so next one, number of round-robin IO size. ESXi round-robin path selection plugin balances the among the all active paths, so it selects the paths and uses it until the specified amount of data is transferred. Let me show you that one. Okay, so here's our little demo stand using the vSphere environment. Okay, just a second. So if we will go to the SCSI software adapter, we can see several network paths active. And yeah, something like that. So the next path is selected and utilized after the specified amount of data is transferred. So this amount of data is measured in this limit, which is set to 1000 by default. So this means that once 1000 IOPS are sent over the path, the next one will become utilized. So to increase the performance by utilizing more paths in parallel, it is recommended to change the IOPS limit to 1, value 1. As a result, all paths will be utilized more frequently. Okay, so let's get back to our presentation. Next slide, about the advanced network protocols such as iSCSI and ISER RDMA. So when it comes to iSCSI, TCP and UDP protocols, all applications that use them are processed by CPU. The 4 data paths must stand in the queue with other applications and system processes for their turn. So that's how the bottleneck occurs on the network layer because of the network latency increase. So the option would be to use the RDMA technology and its extension named ISER, which was designed especially if you're using iSCSI protocol within infrastructure. So generally speaking, RDMA supports zero-copy networking by enabling the network adapter to transfer data from the wire directly to application memory or from application memory directly to the wire, eliminating the need to copy data between applications memory and the data buffers in the operating system. So such transfers require no work to be done by CPUs, caches, and transfers continue in parallel with other system operations. So this reduces the latency in message transfer. So the ISER in turn completely eliminates the problem of network bottleneck by supplying higher bandwidth for block storage transfers. Furthermore, it ensures the highest performance in the clustered systems by avoiding latency issues. Moreover, ISER protocol reduces the CPU workload, which is especially important in hyperconverged platforms where the CPU resources are used not only for virtual machines. So additional free cores will allow you to get more VMs in the infrastructure. Okay. And moving to the next one, the stretch cluster. So in a stretch cluster, the joint servers act as a single system and provide high availability and load balancing for the services, at the same time not being tied to single location. So basically, the cluster nodes can be located in different buildings or even cities. Thus, it is important to have the redundant networking within the stretched configuration. So at least 2 switches in each location connected to another data center via separated networks, And the additional heartbeat channels of the vSphere environment can determine networks being down and prevent split brains, like we do in our Starwind virtual SAM software by using the heartbeat functionality. So yeah, like the information about stretch clusters you can also find in my previous webinar that is available on our official YouTube channel. So check that out. So I guess that's all. Pretty much that's all. So next one will be the questions and answers time. So if you have any additional questions on the vSphere fine-tuning and how to work with that, feel free to write down the questions into the question tab. So the Dave Dankhouse asks, does the stretch clusters require both to be identical? Not really. So the nodes can be quite different in terms of hardware. But in order to get your cluster with proper of performance, it is recommended to make the clusters, make the nodes basically the same. So you will be sure that you're utilizing 100% of each node's hardware resources, basically. Just because if you're clustering two different nodes, the cluster would work with the performance of the weakest node in this case. Okay, waiting for the questions. Maybe other questions, non-vSphere related, are also accepted. Ask them. So Bogdan Daja asks, what is the minimum bandwidth for this kind of cluster? So basically, if you're talking about stretch clusters, it depends on the replicating technology as well. So if you're talking about Starwind as an example, we require at least 1 gigabit networks between the server rooms in order to perform the cluster and in order to work it properly. But in case of, for example, like active passive replication, so in this case 100 megs would be enough for such kind of replication. But of course, the drawback of this is the downtime, basically. So you will have extended downtime within the active passive scenario. So Dave Denhouse asks, I missed the first 10 minutes. Did you go through anything in the vCenter? So basically, we just did run through several options within the NUMA nodes, etc. So you will be able to see that in the recording that will be available, I guess, next week, something like that. So basically, this is the informative webinar, so not really much to show on this webinar, so I can really show the center itself. And all mentioned tunes by me can be found through the functionality of the vCenter, basically. So if we're talking about the number of IOPS, we can use the network adapters, we can use the SCSI software adapters. So as you can see, we have here number of active paths, in order to provide high availability to the system, and in order to allow virtual machines to migrate instantly if something happens with one of the nodes. And regarding the storage, so if we will go to the properties of one of the virtual machines, edit settings, we can see that we have the provisioning on the storage. So if we will add new device, for example, the hard disk, we can specify which disk provisioning it has. So usually we take the thick provisioned eager 0. Here's the one. And we can set here as well number of shares, as I mentioned previously, and also the numbers of IOPS. So you can set some IOPS limitation in here as well. So everything is covered by the virtual machine settings. Okay, so maybe any other questions regarding vSphere or not regarding vSphere, maybe regarding StarWind Virtual SAN, what we do within our company, or maybe Hyper-V, because we're also using the Hyper-V hypervisors to provide highly available data. Okay, still waiting for the questions. I bet there are a few more questions you have. So meanwhile, if we will talk about the proper compute provisioning of the vSphere environment into words like over provisioning the environment is bad, and provisioning less resources bad as well. So we need to reach the value that is needed just for your existing infrastructure, and including some of the future growth resources. So something like that. Okay, so at the moment I see any questions left. So if you will have any questions further, you can ask them now, or you can, of course, ask them later in our social media. Okay. So I believe there are no questions left. So thank you again. Thanks for your time. Okay, one more question I can see. So Christopher Middleton asks, I know the NVMe isn't supported yet on vSphere. Do you have any recommendations to get the most out of them? So basically, NVMe can use a single storage within the vSphere environment as well. The only thing is that there is no existing RAID functionality, hardware RAID functionality for the NVMe drives. And yet we're looking for such functionality, but in case if we will use the if we will build the HE environment using the NVMe drives, so it will be limited by the software RAID. So we can use some of the soft rates in order to do that. But there is a IOPS limitation, some kind of IOPS limitation using the NVMe drives nowadays. So that's no technology of the hardware rate for the NVMe drives is created. So we're awaiting for them, something like that. Okay, so rest of the information you can find on our portal. So if you don't have any questions left, I'm going to thank you again. Thanks for your time, and that was a pleasure for me to speak here about our about the vSphere functionality and vSphere fine-tuning. So, okay, bye-bye and fly safe. Thank you one more time, and have a great rest of the day.